Problem. Okay, now I think it's recording. All right, well, officially, welcome everyone to our Capstone presentation for 2024. We have two teams tonight to present. We're gonna do them back to back from 6 to 6:30 and 6:30 to 7. And the first team, they will present themselves. I just want to remind the rules. Each team will have 30 minutes. 15 minutes they're going to present, and this next 15 minutes they will take questions. Initially, the questions will come from the advisors and the sponsor of the team, and then the floor will be open to anybody else that would like to contribute or ask questions. Okay, so let me see. Team one, are you ready to go?
Yeah, I'm ready.
Alrighty, so
Yes, I'm
put
ready.
the slides on. Great, and go.
Okay. Good evening, class. I'm Rosa Estrada, and this is my partner Yi. I would like to say thank you to the program director, Dr. Jody Reeves, our instructor, Dr. Mario, and our two advisors, Dr. Renee Hendricks and Dr. Mendoza Rivera. Today, we will be proposing our research topic on loan default for our data science capstone project. In this presentation, we will be focusing on our research question, important statistics, the benefits of studying this topic, information on our data set, our variables, literature review, along with any difficulties we may encounter, and lastly, our methodology. Let's take a look at our research question for this project. The first question our research aims to answer is, how can borrower details, financial attributes, and potential interactions predict loan default for loan issued between 2016 to 2020 using advanced machine learning techniques? The second question our research aims to answer is, could the occurrence of natural disasters like wildfires or earthquakes, as witnessed in the United States from the period of 2016 to 2020, be used as predictors for loan defaults? These two questions will help us provide a roadmap and foundation to our study. Let's take a look at a few statistics regarding this field. According to Consumer Financial Protection Bureau, the 30 to 89 days mortgage delinquency rates identifies early stages of borrowers in meeting mortgages payments, serving as a crucial indicator of potential stress in the mortgage market. This information contributes valuable information. The trends that are shown in the graph of mortgage payment issues helps us understand the role of home ownership, which is a variable in our study, and the potential loan defaults it may provide. National Oceanic and Atmospheric Administration states that the United States has sustained 376 weather and disasters since 1980, where overall damage cost reaches or exceeds $1 billion. This information relates to our research topic because it shows us that the U.S. has had many costly weather disasters. We can see these events significantly affect loan defaults and figure out which money-related factors are most impacted. Yi will now discuss why it's important to study this topic, followed by an introduction to our dataset.
Thank you, Rosa, and good evening, everyone. So, all right, let's get into why this topic really matters. Think about it. When we know why loan fall through, lenders can get ahead of the game. They can cut down on risk and make sure they are putting their money where it's safe. Now consider the curveball thrown by natural disasters. If borrowers get the effects of how this events mess with loan repayments, they can bring themselves financially. It's like checking the weather before a trip. You want to be ready for anything. Every day, people using this info can dodge financial headaches. It's about making a smart move with your cash, knowing what's up ahead. Finally, this isn't just number and predictions. It's a real life stuff. People and business in disaster zones can use these insights. They can get their finances stormproof, ready to weather whatever comes in their ways. Now let's take a look at the data set. So let's get into our heart of project. We've got a data set which is Lending Club data from Kaggle, and we're merging that with dataset disaster declaration dataset from Federal Emergency Management Agency. We're focusing on the years through 2016 to 2020 to see whether the numbers will tell us about the loans and the natural disasters. Now we're talking about a huge amount of data here, 2 million rows and almost 150 variables. But we're zooming in on like 24 key variables to really get to the heart of what affects loan defaults when natural disasters strike. Through this data set, we're trying to figure out how these big natural events affect loan defaults. And we are looking for ways to get a better when we're facing these unexpected challenges. That's a goal. Now we will look at what it will look like.
Here is a sample visual representation of our merged data set, integrating Lending Club loan data and U.S. natural disaster declarations data. We merged these data sets by using the variable state. I would like to note that although they are merged, our final data set is still in the beginning processes of the data cleaning cycle. This merged data set will give us the ability to address our research questions, the first being how borrower details, financial attributes, and potential interactions predict loan defaults for loans issued in 2016 to 2020. And the second research question being, could the occurrence of natural disasters like wildfires or earthquakes in the United States from 2016 to 2020 be used as predictors for loan defaults? Let's take a closer look into the variables being used. In our data set, the variables are not shown like this, but we made them readable for the viewers. Our proposed target variable for this study is loan status, which signifies fully paid and charged off. Fully paid resembles a loan that the borrower successfully repaid, whereas charged off resembles a declaration from the lender that the loan is not likely to be fully repaid. Our independent variables that might impact the target variables are categorized under loan information, borrower information, loan details, and the variables from the natural disaster data set. We strongly believe that these variables will play a significant role in influencing loan status. We aim to uncover patterns and relationships that can contribute to answering our predictions. Yi will now discuss what the researchers Shirish and Poyan investigated and why we are interested in seeing if it applies to our data set too.
So this is an early study. Shirish point out something striking. Big storms like hurricanes and floods are often followed by more borrowers struggling to pay their mortgage. Take Texas in 2017, for example. Figure 1 shows right after Hurricane Harvey hit, there was a big jump in people defaulting on their homes. And this wasn't the first time we see this. Alabama and Mississippi had the same thing going on, which we can see in figure 3 and 2. Based on what Shirish found, we are now digging into whether disaster could be a key factor in predicting when loans might go bad. Next slide, please. So first, we've got the data clean circle. It's a big job, like merging data, filling in blanks, standardizing, and getting rid of any doubles, like duplicates. It's all about setting stage for clean analysis. So next is processing speed. What I mean is processing speed is like with this huge data set, we will take more time, and the machine will take more time to handling the whole process. And we can skip over the dimensionality challenges. With so many variables, we'll get to zero in the ones that matter most, cutting through the clutter to find the gold. In short, we've got our work cut out of us, but each step is crucial to make sure our findings are solid. Next slide, please. So first, we'll merge two data sets with the variable state. And then we start with a good understanding of the nature of the data set including types of variables and the potential relationships with target variable. And then we will clean the data set by removing outliers, handling missing values, standardizing data if needed. After that, we explore our data. This may include EDA, visualization, and summary statistics. Next slide, please. We will also perform feature engineering, like creating new features, normalization, also imputing missing values using the mean or median as we need it. We may find it necessary to create additional variables and perform label encoding and one-hot encoding methods. After that, we could do chi-square tests to identify variables strongly linked with our target variable. And we can also create a Pearson correlation. Since the target variable long status is imbalanced, we will explore oversampling techniques to assess their potential impact on model accuracy. Next slide, please. On this slide, we'll see our machine learning process starting with splitting our data set into training and test sets. The training set is where our model learns to predict long defaults, while the test set is for ensuring our models can handle new unseen data. We're applying 4 key models here: logistic regression, decision trees, random forest, and finally the gradient boosting. Next slide, please. So to compare different models, we first look at the confusion matrix and also the F1 score, precision, and the recall matrix. We could also check the RC and the AUC because it gives us a single number to tell us how well our model is doing overall. With the best model, we can do the feature importance analysis like SHAP or feature importance scores to identify which attributes most significant predict long defaults. Next slide.
Thank you, Yi, in guiding us through our methodology. In conclusion, these are the factors we focused on in today's presentation. We stated that we want to research if borrower details, financial attributes, and potential interactions can predict loan defaults for loans issued between 2016 to 2020 using advanced machine learning techniques. And if natural disasters like wildfires or earthquakes, as witnessed in the United States from the period of 2016 to 2020, can be used as predictors for loan defaults. We discussed the potential challenges we may face in the beginning stages of our data processing and cleaning cycle, along with how our potential algorithms will help us answer our research question for our specific data set. Thank you. Here are our references. Any questions?
Okay, thank you, Team One. Let's have questions from the advisor first, and then we can open the floor for anybody else that wants to add questions.
So Rosa and Yi, I actually have 2 questions. One is, and this is probably based on the data set, how is default defined?
Hello?
Yes.
Oh, now you could hear me. I would say the best way to define default would be through our target variable, which, let me try to go to that slide. Right here, which represents either if a loan was fully paid off or charged off. So I think the best way of knowing if it was default is by using this target variable.
No, I agree. And sometimes when they refer to charged off, they may or may not refer to the amount of time, which many times that can be like 90 days and so forth. So it may or may not have the details, those details. It may just be fully paid and charged off. Another question I have is, do you think, especially when you think about natural disasters, depending again what types, if they're fire,
Yeah.
hurricane, flood, do you see covering all states, or do you think it will only end up being certain states that tend to be affected by those?
I think it'll only be certain states because we looked at the data set earlier today and last night, and we noticed how big our data set is and how much information it's giving that we might have to limit it to certain states. We're probably thinking California with the earthquakes and fires, or some winter storms over in the east side.
No, I agree. And I believe Yi is the one who referenced that study that the charts are from, where it shows Texas, Alabama. There's only about 10 states that are listed in that study. So I wonder if it'll be the case, which can happen.
Yeah.
But thank you. Those are my questions.
Thank you.
One question, Rosa. I noticed that, okay, it's well organized, the presentation. The independent variable look like are well defined, but there are some categories for the independent variable: loan, borrowed, detail. Then you are thinking to how to tackle the dependence between these variables, because loan amount, long-term interest rate will be dependent variables, and if you are going to use the logistic model, this is something that you have to, I know that you are considering that will be independent, a relationship between this independent variable, yeah?
Yeah.
And, okay, you are considering how to tackle this problem. That will be.
Yeah, we know that, especially in the loan information category, it's giving us kind of different variables that we can choose to work with, either the loan amount or the loan term, if you want to focus on like a span of how long the term lasted, or even like the interest rate. So there's definitely these variables that we need to kind of select and make our key.
Okay, then are you considering also an all procedure for selecting variable, like stepwise and forward and stepwise, and that kind of procedure to select variable? There are some procedures for selecting variables. After you define all possible variables, you need to decide which variable should be the best into the model, and before to put into the logistic regression model. Then are you taking account that kind of procedures, like stepwise?
Yeah, we are definitely taking that into account.
Okay. And then another detail maybe there is taking account the assumption of the model. Yeah, how to measure how good are the prediction. Okay.
Okay.
That's all. Taking account this kind of selection methods, okay, and tackle the relationship of the variable within each category, and for sure should be relationship. Okay.
Okay, thank you.
You're welcome.
Hi, this is Dr. Reeves. I had a few questions as well. One of the important things, and you'll start writing about this in chapter 1, is the limitations of your study. What do you see either in the data, the methods, or other areas? What do you see as limitations to do your study?
That's a very good question. Let me think. Because we were actually compiling all of this, but we actually kind of left out that very big detail of like what our key limitations would be in this study. We are thinking the biggest one would be how to like really implementing the natural disasters data set, kind of really honing in on that second research question and making sure that it's good enough to be a predictive research question.
Well, let me guide you in a different direction. For example, you said that you're using the data from 2016 to 2020. Why are you only using those years of data?
Oh, good question. We decided, well, the data set goes all the way until 2007. We could initially still do 2007 up until 2020, but we thought with how big the data set would be, it would be best to just limit it to 3 years. So we decided to do the most recent years, those being 2016 to 2020.
Well, you might want to think about that in the next couple of weeks because I can understand a lot of data analysis these days stops at 2020 because the pandemic, changed so many things. It's really a unique set of variables in itself.
Yeah.
But as you start exploring, especially your natural disaster data, if those last 3 years there weren't very many of them, you're going to have to go back further in time. Otherwise, you won't have enough data about natural disasters to make any sorts of predictions. And related to that, you've talked about overall loan default, but do you specifically mean just mortgage loan default, or are there car loans or other kinds of loans included in your analysis?
In our data set, it's actually for loan default. It's mainly mortgage under the house ownership variable, and it's mortgages and rent. As of what we've seen from the heading and from the print of the data set.
Okay.
So we have to look in more into seeing if there's car loans, student loans. If there aren't student loans, we were thinking of finding some way of maybe seeing if that would be a factor or.
Right. So that's going to be one kind of limitation. If you have many different kinds of loans, depending on the data you have for each kind, you may or may not have enough to do analysis with. And that comes back to something I think Dr. Rivera was asking before. You've talked in 2 slides. On slide 7, you talk about key variables, and on slide 11, you talk about meaningful variables. But how are you going to choose out of dozens to over 100 variables? How are you going to choose what is key and what is meaningful?
Oh, I see what you're saying. I think the biggest thing is looking at our research question and seeing what can make the biggest impact in predicting loan default and deciding if those key variables are fit for it. And if not, we would have to go and search within one of the other variables. But we did notice that, yes, there's 147 variables, but a good chunk of them are null variables and they don't have data in them. So it kind of narrows it down to a very, not 147.
Right. So keep in mind there's certain statistical tests that you can do on the data to see which are important to keep. I don't think you mentioned that in your methodology, but you'll need to decide that as you start doing your work. And specifically, one variable I'm most interested in here on slide 9, under natural disasters, you have both state and postal code. So it's good to have the granularity of the postal code data because that gives you a certain geographical range. But where are you going to tie the postal code data of natural disasters to any postal code data about the borrowers? I don't see that in those 3 columns.
Yeah, that is something we definitely need to look into when cleaning it out and seeing our variables. I know we merged them by state, and postal code would be a great variable to have, but I don't think our loan default data set has postal code listed.
So do you think that's going to be a major limitation? Because in California, you could have a dozen wildfires going on on any given day.
Oh,
Some
yeah.
might only burn a couple hundred acres and be put out in a day. Others will burn 100,000 acres and go on for weeks. So that granularity of your data is also going to be a limitation you'll need to consider.
Okay.
And finally, Yi, maybe you can speak to this one. On slide 14, you talk about train and test data. What percentages are you going to use?
Uh, I think I will go like 75 to 25.
And how are you going to deal with the unbalanced data that you have?
I think I would do the smoke if I pronounce it correct, SMOKE, and then the oversampling.
And finally, what specific tools are you going to use? R, Python, SAS?
Yeah, we're considering only use the Python for the whole
Python?
project.
All right. I know that was a lot of questions. Thank you both very much.
I
Thank you.
actually have a question. Talking about the programs, I was also considering using SAS because I know it can deal with a lot of complex data sets. But when I tried to access it, it didn't give me access anymore. I don't have that student permission. So I was actually going to reach out to you, Dr. Jody Reeves, about that.
Absolutely. Please email me, Rosa, because I was just talking to our lab manager this morning. We have licenses through April. We're just starting to renew them. So you
Okay.
should get that access.
Okay,
No
thank
problem.
you.
You're welcome. Good job, team. Thank you.
Thank you.
Dr. Zettner, did you have anything to add? I see you left a comment some time ago.
I did. I'm legit inside of an airplane right now, but it really tied back to what Dr. Reeves said, where how are you defining really the time frame from the natural disaster to the loan default? So imagine if you looked at a year and say that the disaster happened in December, but the default happened in like February, could you really draw that connection? Is there a time frame that you're looking at from when disaster occurred to default occurred? Because in theory, it's not going to happen on the same day or in the same month. I think other areas you want to consider with that is how, like what Dr. Reeves said, what's the proximity to that? I'd say also looking at various census tract variables that you can bring in to look at what factors are influencing what's occurring in that data set beyond the natural disaster, because it's kind of really broad. Honestly, it's a really broad reach for that. Trying to tie someone didn't pay their loan because there was a fire like 500 miles away. I think how do we draw that connection closer and seeing how that ties back to it? And I think back to the question about loan defaults, if you can refine it better to something like you said, mortgage or something, because if you recall down the 2020 lane, they were dialing back a bit on student loans. Like we all had our loans put in default automatically. We all had renters almost protection for quite some time. And so thinking about that, maybe looking at the framework of the model pre-COVID, and I know you don't have data post-COVID, but that could be something for future research and maybe dialing it to that level for those connections. Sorry that the people are talking over the airplane. Those are some of my questions.
Those are really good insights that we'll have to also keep into consideration with really narrowing down on the time frame and how we can make that connection between natural disasters and loan default. I think it's kind of ties with it being a big limitation, kind of like Dr. Jody Reeves pointed out. So it's something my partner and I will have to really sit down and talk about more.
That sounds great. Look forward to seeing the study.
Thank you.
Yeah, I have just one more question. I am Shada Jawad, and I have a question. Who will get benefits from this result? Like, after knowing everything, who will be like the user for the system? Is the customer will get benefits or the company who provide the loan?
I think it would be both. We listed here kind of not like brief overview of who will benefit from it. And it goes from both the lenders and the borrowers. We're seeing more of like the lenders can see how they can pitch their interest rates to lower it or raise it depending on those loan defaults, given those variables that contribute to it. And then natural disasters, it can also help borrowers see what area they're living in and how their loans can be altered or affected given those areas.
So that means we need to define the area and the type of disaster and the type of loan. So I agree with the other faculties that mentioned these are so important factors that we have to be careful when we select them, because when the people will need to get answered, it's depend on these factors.
Thank you.
Thank you.
Okay, great. Great work, Team One. Thank you all for all the great comments. And now we're going to jump into Team Two. Team One, can you release your share screen? Great. Team Two, get ready and take it whenever you can.
Yeah, thank you. Can you all see my screen?
Yes, it's good.
Okay, good. First, welcome everyone. First, I would like to express our gratitude to Data Science Department that have Dr. Judy Rees is the program director, and our Capstone project instructor, Dr. Mario Misekan, and our project advisor, Dr. Jawad Setar, and all committee members here today. We are Team Triforce Analytica. We are Elisha, Henley, and Magnus, students in the master degree in data science program. Our logo is on the edge left corner here, you can see. Today, we will explore how data science can unlock the new possibility in crime prediction in Los Angeles. Our goal is to use machine learning to prevent crime before it happens. We start by mapping out the critical component of our project, include its background. We will explain why crime prediction in LA is essential. We will provide proposal for a research question. In the literature review section, we will summarize the existing research on crime prediction model. Our journey will explore two primary data sources. First is the LAPD dataset. It's the primary data source, and the second is the weather dataset. We will highlight any initial observation about the dataset to understand the data characteristic. Another angle is the methodology, and we will explain why data processing and what are the challenges and the potential algorithm and technique that we are going to use. Last but not least is the conclusion that will summarize the key points covered throughout our presentation. Why? Why this project is important? Mainly because the crime increased, and we can see that we can use data to prevent it. Look, the crime trend over a decade, last year itself, it rose exponentially. It was different from 2022 versus 2023. The trend day by day for entire week overall is similar, which ranked from 800 to 900 cases per day. On August 4, 2022, the LAPD increased its patrol force by 200 more officers in Hollywood to combat rising crime. The question is it practical and is it enough? Our technology can help to predict the crime that can occur and allocate resources at the right time and location. We will explore significance of our work, including crime reduction statistics, by harnessing data science. In this slide, we will outline our research question and proposal, which serve as the foundation of our project. This question guide our analysis and are central to our project objectives. First, what are the hotspots of crime occurrences in LA? And how can we predict the type of crime? We propose to investigate factors such as time of the day of the week, geographic location, and type of crime in LA. For the second question, what are the role of the victim demographic play in crime prediction? We intend to explore relationship between demographic variable and crime type to identify potential pattern or trend before they occur. Last question, do specific weather conditions in LA influence pattern and frequencies? We propose to construct a model to explore the correlation between weather and crime aiming to guide law enforcement in resource planning based on weather crime trend. In 2018, Stack Clapjan began blending neural network with weather data, shaping our broad approach to predicting crime. Following year 2019, Kalanfi and Koso show us how to use LSTM to identify crime type and location, which help to pinpoint where crime may happen in LA. In 2020, broad insight from Mandalupus team who use ONN to track crime trend over time, a key factor for our predictions. Also in 2020, McKessler research on LSTM ONN deliver high accuracy in crime forecasting. It's reinforced our current prediction method. Jumping to Zoo 2022's work, we see LSTM with attention mechanism enhancing our ability to make detailed prediction. These studies are the pillar of our crime prediction model. Next, I will turn it over to Magnus.
Okay, so I'd like to say thank you, Hengli, and good evening, everyone. So our data set is owned by the LAPD. It's called the crime data from 2020 to present, and it's sourced from the LA Open Data Portal, which is one of two sites that is dedicated to sharing real-time data on LA. The other is GeoHub. So now this data set is updated weekly. It's updated weekly, but for the purpose of uniformity, we shall be dealing with exactly 4 years worth of data, which is from January 2020 till December 2023. It contains it contains 764,061 records and 28 features, which contains crime records in LA over 48 months. We can see a snapshot of the first 3 rows of the data set on our screen. Our next slide, please. Okay, here we classify our 28 features into 5 categories of W. We have who, when, where, which, and what. Who refers to who the victim of the crime is. We have the features like the victim age, victim sex, descent, which is race, and the division of records number. The when refers to the time or day that the crime happened. We have the features like the date it was reported, the date of crime occurrence, and the time of occurrence. Where refers to the location, of course, where the crime took place. We have features like area. An area is actually sequentially numbered from that was 1 to 21, which represents the 21 community police stations all over LA. The area name gives the name, the area designation. We have others like the report district number, the location, which is anonymized to the nearest 100 block of the street address, and because of data privacy and concerns. We have cross streets and also we have latitude and longitude, which refers to which type of crime was actually committed. We have, so of course we have the part 1 and 2, that's where the part 1 are actually the more serious violent crimes, and part 2 are the less non-violent crimes. We also have crime code and their description. We have crime code 1, which is actually the primary crime, and codes 2, 3, and 4 are additional crimes that were perpetrated by the suspects. We also have more codes which refer to the activities that were associated with the suspect at the incident of the crime. Then we have what, which refers to, of course, what was used in the crime. We have the weapons code and their description, and we also have the status of the case and the description. On the right side of the screen, we have our proposed target variable, which is crime code description, which in essence is a classification of the crime into distinct categories. Next slide, please. So to gain additional insight into the crime type, we shall add the early weather data from January 2020 to December 2023 to our crime data set. This early weather it has 7 distinct features. That's namely the date of occurrence, the temperature, dew point, humidity, wind speed, the pressure, and the precipitation. Apart from the date of occurrence and the total precipitation, which are on the extremes of the table, the other 5 features are each grouped into 3 features of maximum, average, and the minimum values. The data has 1,461 records. Our next slide, please. Now, okay, since they actually span across the same time period from January 2020 to December 2023, we shall merge both data sets by the date of occurrence variable. Our combined data set will have a total of 44 features. With these, we can predict the crime type and the location or the hotspots of where the crime occurred across LA. We can also understand crime patterns due to weather and other factors. And we can also gain insights on the role of victim demographics in crime prediction. Our next slide, please. Now, our target variable, of course, which is crime code description, has 138 categories. And however, our EDA reveals that the top 10 crime categories account for over 62% of the total crime types. It's intriguing, however, that the top 15 categories account for over 78% of the total crime types. And as we can see on our screen, the most common crime category in LA is actually stolen vehicles, with over 75,000 occurrences, which is about 10% of the total crime types. This is followed closely by, as in simple assault battery. We also have burglary from vehicle. We have burglary and identity theft round up the top 5 crimes. Now over to Elijah for insights on our methodology.
Thank you, Magnus, and hello, everyone. Elijah here, and I'm going to be discussing the methodology portion of the project. So we, Triforce Analytica, will be utilizing Python along with the CRISP-DM methodology to analyze Los Angeles Police Department and weather data to aid us in answering our research questions, which again are determining future crime hotspots and types of future crime in LA, determining the role of victim demographics in LA crime, and discovering how weather impacts crime in LA. Python allows us to implement several different types of machine learning and AI algorithms using libraries like scikit-learn and TensorFlow. Magnus and Hengli have already covered a good portion of the beginning parts of CRISP-DM and its lifecycle methodology that we plan to implement. So I'm going to go through our initial ideas on how we plan to complete the rest of the cycle and develop the most accurate models that we can. Next slide, please. We do expect to have some initial challenges, and more may develop as we begin to manipulate our data more. But initially, we expect to see some of the following issues. Data quality. We've performed some basic EDA and noticed some anomalies in the data set that I will cover in the next slide. Model fitting. We suspect to spend a significant portion of our time on tuning models to avoid over and under fitting so that our models will generalize properly. Model interpretability. As we plan to use a wide variety of techniques to find the one with the best performance, we suspect a trade-off between interpretability and accuracy when using more advanced techniques like neural networks. We'll have to find ways to make our models as transparent and interpretable as possible. Bias. Our data contains large amounts of information on victim demographics. We need to be mindful of this and implement fair algorithms and other bias detection mitigation techniques like reweighing training data or adjusting model decision thresholds. Next slide, please. So as I previously mentioned, we've encountered some data anomalies when we were conducting a brief exploration of the data set. We can see on the left here that there are a large number of missing values. The missing data can be problematic when answering some of our research questions, such as missing values for victim sex and descent when trying to determine the influence of victim demographics on crime prediction, as well as greatly impact the accuracy of our models. On the top right, we see that the minimum age is negative 12 years old, which is a clear data entry issue of some kind. The bottom right, we see that the earliest years in this data set are 2010 and 2011, which is far out of the range this data set is supposed to be inclusive of. We need to perform more analysis to determine if this was an entry issue of some kind as well. And last, we see a huge surge of crime in 2023 and a dramatic left skew of crime amounts by year. This can be for a variety of reasons, such as the increased police force Hengli mentioned when performing more arrests, new reporting methods, and so on. So to address these issues and clean our data, we'll set up validation rules for problems like negative ages, perform statistical imputations for missing values or drop them, and employ temporal normalization to help eliminate bias that may be influenced by year. Next slide, please. So after we address the data integrity issues, we'll then proceed to splitting our data to prepare for training our models. A training set for learning the initial patterns, a validation set for hyperparameter tuning, and a test set for unbiased assessment of model performance. We're considering a few different ways of data splitting, such as random splitting or chronological splitting, to see which type will help us produce the best models. At this point, we have not determined the seasonality of crime in Los Angeles, which could impact chronological splitting. Also, if we implement random splitting, we need to consider adjusting the weights of the data. Ultimately, we plan on looking into a wide variety of techniques and split percentages to help minimize bias and improve model accuracy. So these splitting methods and percentages may adjust quite a bit as we learn more about the data. Next slide, please. So for the final portion of our methodology review, I'd like to discuss a few of the models that we plan to use to answer our research questions, as well as discuss a little bit about previous research that has seen success with employing similar techniques. For example, support vector classifiers are a method we plan to help us answer our research questions on determining crime hotspots in LA. In 2021, Shaw utilized support vector classifiers and other models to achieve an accuracy of about 75% in predicting crime locations. This model may be useful for victim demographic classifications as well. Several time series studies related to crime prediction have also shown success when employing techniques like recurrent neural networks, ARIMA, and long short-term memory networks. For example, in 2018, Steck and Klabjan utilized these techniques to achieve a 25 to 30% higher accuracy than the base model in Chicago and Portland. We plan to implement these techniques initially, tune them to be as accurate as possible, and continue to try others we see fit as we develop a better understanding of the data. Next slide, please. So to conclude our presentation on the LAPD crime prediction project, we will be conducting the full data science lifecycle and implementing advanced AI and ML techniques to answer our research questions, which again are future crime hotspot predictions, victim demographic role on future crimes, and weather's impact on crime, all of which are in the city of Los Angeles. We'll be standing on the shoulders of giants such as Shaw, Zhao, Mandelapi, and Conlon Fayed, who have utilized many similar techniques and shown some success in other cities on similar topics like recidivism in their recent research. So our project isn't without its limitations. Our model's predictive accuracy is tied to the historical data available and is also geographically limited. As crime patterns may change, models will need continuous refinement to maintain their accuracy. And additionally, our current data set does not include perpetrator demographics, presenting a limitation in understanding the full spectrum of crime dynamics. But despite these challenges, our focus on model tuning and optimization is designed to ensure that our predictive tools are as precise as possible and offering the LAPD actionable insights for crime prevention. That concludes our presentation, and we would like to open the floor for any questions, please.
Great, thank you, Team 2. Let's give the first word to the advisor, Dr. Jawad, and then we open the floor for other questions.
Thank you so much. Team, thank you so much. It's a great presentation. It's have everything that I want to be in the PowerPoint. So I appreciate that. I have actually two questions. The first question is, how are you planning to merge these two data sets, the weather and the other data sets? Because you didn't mention there is like area with the LAPD. So there is no area, as I noticed in the data sets of the weather. See the variables. Is there anything else that it is not listed here? So you can merge like each row from first data sets to be matched with the second one, or it will not be like row by row?
Okay, so I would answer this question. Like we're using the early weather data set, and the data set, of course, actually accounts for the whole of LA. It's not just a specific location within LA. So we had to, of course, actually, we try to actually search for this data set, and it actually took us a while to be able to get this, but this actually covers the whole of LA, and all we're doing is we're merging by date of occurrence.
Okay,
so
great. Yeah,
yeah.
understood. Yeah, I got it. So this is the weather of LA, and you will take it as day to day, the crime, how it will go. And yeah, my second question, you said there is 10 the most crime happened from others, like different other crimes. Are you looking just for these top 10 crime type to predict, or you will include all kinds of crimes?
Yeah, so of course we have, of course, like you can see on the screen, we have about 238 crime classifications. So all we just did was just to actually give us a snapshot of the top 10 crime, as in the top 10, as in the categories. And of course, like I also mentioned, as in the top 15 accounts for over 78% of the total crime types. So, and it means that we have some crime it means we have some crime categories here that actually had just 2 occurrences. Like on this very data set, we have incest, which has only 2 as in 2 categories. So it's not like there's not a common type. So I think we would have to eventually focus on the main,
Yes.
on the exactly on
Yes.
the on the most common crime categories, because that would help us to actually predict that what kind of crime is more likely to happen in what location.
Yeah, and your project will be more specific. Thank you so much. Great job. Thank you.
Thank you, ma'am.
Yeah, I am done. Thank you.
Thanks, Dr. Jawad.
I'll leap in with a couple of questions. You talked about your literature review on some of the methodologies that had been done in these kinds of studies. Have you seen anything in the literature about how having biased data will affect your results?
I have not seen it. It's because I have not seen any specific examples of it, but they do tend to skirt topics of like racial profiling. And on our particular case, we're using victim demographics, not perpetrator demographics. So it kind of mitigates that a little bit, since it's not, who the police are arresting. It's but to short answer is no, I haven't seen anything significant.
Just want to add a bit thing, like Dr. Judy. Like according to our literature review, Mendelepi and Miss Keller did mention about the accuracy of the on-end and LSTM can impact by the quality of our data. So with the data set, if it could link to bias if it have the issue with the data set.
Yeah, and especially here in LA, you hear a lot about racial profiling in the arrest for the perpetrators. So that's interesting that you're not looking at that. You're looking at the victims. I think another thing that helps you is you had mentioned seasonality. Weather, of course, is seasonal. It'll be interesting to see if there's a seasonality in crime, but that seasonality is much more muted in LA than say Chicago or other cities that have more severe weather. So you did a good job covering a lot of the limitations, but there was one major one that stuck out to me, and that's the impact of COVID. When so many things were shut down, especially 2020, I'm thinking a lot more people stay home and there's a lot less crime. So how are you going to for example, as I look at the crime results over the years, you talked here and on another slide about 2023 being a huge spike. It's possible that before 2020, that was normal crime, and those smaller bars are partially because of COVID. How are you going to deal with that?
So I could take this one, Hangley. So absolutely, and I also thought about bringing this up, but we do have access to more historical data. We just didn't include it for this because we weren't sure if we needed to add more data. We actually have data going all the way from 2010 to 2023, so we could definitely perform an analysis on that to see if we see that trend as well.
I think that'd be very valuable, Elijah, especially just at the EDA level, to see if 2023 is an abnormality or if 2020 up through there are the abnormal ones. I think that'll help your study. And my final question, you talk about the 5 W's. I didn't catch what slide that was on. Who, what,
Yeah, that's
where?
6. Yeah, that was slide 6.
Okay. So exactly what are you going to predict? Are you going to predict the crime? Are you going to predict where a crime happens or where a specific crime happens? What's going to be the granularity in your prediction?
So our target is actually the crime code description, so which actually describes the crime code, because we have the crime code, which is just numbers, and then the crime code description, which actually states if it was a stolen vehicle, if it was burglary, and all of that. So we have 3 research questions, of which number 1 is about having to actually predict the hotspots, which is the areas where we have more crime or the most crimes. So of course, we actually want to be able to predict the area. Of course, it means our target variable in that case might just be area name. But apart from that, we're also predicting the crime type, which is where this comes in. The crime code description comes in. We're going to be able to predict that. And then as well as also have a look at the role of victim demographics on the type of crime that is being perpetrated, basically.
But you realize those aren't truly independent. Those are going to be tied together. There's certain, say, zip codes in LA where you're going to have a very different demographic than other zip codes. So keep in mind the connectedness between your variables that might have an impact. And that was all my questions. Thank you. Good job, team.
Thanks, Dr. Reeves.
Thank you, Dr. Reeves.
Thank you.
Thank you, sir. Mr. Aaron, as in Dr. Aaron, thank you, sir.
Any more question from any of the attendees? Any comments? Okay. Okay, so if you don't have any more questions, then we can wrap it up. I want to thank you both teams for presentations. You held up good. Big thanks to all colleagues, Dr. Jawad, Dr. Rivera, Dr. Hendricks, Dr. Zentner. Thank you for helping our students through this experience. And of course, a big thanks to Dr. Reeves, who's always there to help us, no matter how tough it gets. I don't know how you do it, Dr. Reeves, how you have the time to all this, to all of us, to all the students. A big thank you. And if nobody else has any comments, then we end it here and we move forward.
Thank
Good
you.
night.
Good luck, student. Thank you.
Thank you. Thank
Thank
you.
you, everyone.
Bye.
Thank you, everyone.
Thank you.
Thank you.
everybody.
Bye-bye.
Bye.
Thank you, Professor.